Next, we have, the tag has been working on a document called the societal impact of the web. And Lola kindly agreed to talk to us about digital divide in relation to that document. Do we have Lola online? Yes.
Yes, hello.
Thank you. Lola?
Hello. My name is Lola Odelola, and I am an invited expert and member of the Technical Architecture Group. Over the last 2 years, Amy Guy, former TAG member, has developed the Societal Impacts document, a document to encourage spec authors to think about the social ramifications of their proposed specification. In this talk, I want to show examples of specifications that may have excluded groups of people and their effects, how power dynamics show up in standards, and what has been done in the past to limit harmful impact. In this talk, I will be looking at who is excluded and what are the effects of exclusion. So, exclusionary web features. The first I want to look at today is autoplay, an attribute when used on HTML video or audio elements that allows media to play on page load. So this will be automatically playing videos or automatically playing audio. There are some issues with autoplay because interactive elements on a page should respond to user input. Autoplay doesn't wait for users to interact with the page, which can be disorienting, overwhelming, and prevent some users from being able to use the page as intended. And so, for people who have sensory processing disorders, cognitive disorders, or disruptive to screen reader users, many browsers now prevent autoplay if the audio is not muted. And the Mozilla Developer Network have a best practices guide on using autoplay. Another fix is the prefers reduced motion media query, which allows developers to check users' system settings and only toggle autoplay if the prefers reduced motion setting is off. Another set of web features are frame and frame sets. Frames were a very old way now of for web developers to show content from multiple websites in one visual space or page. And I know this is going to sound very familiar to another web feature that we already have today, but this is different from iframes, and we'll get onto iframes in a minute. And issues with frames were that frames can be disorienting to screen reader users. Screen readers struggle to know which frame is in focus. And while frames are not inaccessible to modern screen readers, they are no longer supported because of the difficulty in trying to make them accessible. WebAIM mentions in their post on frames that they are no longer supported in HTML because of limited support and difficulty in making them accessible. And the fix to frames was the iframe. Inline frames were introduced to address the accessibility issues for frames. Adding a title to an iframe allows screen reader users to read through a list of iframes and identify specific iframes. Font face is another web feature. I think this is newer than iframes, which gives web authors the option to link to custom and or variable fonts, which can be fetched and used when needed. Now, this was a great thing for web designers and front end developers. However, there isn't a limit size on font files, which means font files can be large, which can make them slow to download over 2G and 3G connections or completely fail. The size can also mean that they're expensive to download, both technically expensive and also financially expensive, which negatively impacts people with capped or limited data plans, especially those in rural or poorer areas. While there are no limits in the spec on how big font files can be, there is explicit instruction on how to ensure that for users who may struggle to load font files are still able to use the site. User agents must display the text should the font fail, and web authors should provide fallback fonts. Now, I want to cover some newer tech that may be exclusionary. And the fixes for both of these features I'm going to speak about are still in discussion or still in review. The first is WebGPU. WebGPU provides a low-level access to developers to allow them to render high-performance graphics like advanced 3D rendering. The issue with WebGPU at the moment is that it's incompatible with older devices that don't have support for modern graphics API. According to the GPU for the Web Community Group, this means that over 500 million users are unable to access WebGPU rendered objects. This number is likely significantly larger when including users in the global majority. Now, the proposed fix for this is the Web GPU compatibility mode. The community group have proposed an opt-in mechanism to limit the Web GPU features that are incompatible with older devices and graphics API, and this is currently under review with the tag. Another newer feature is CSS carousels. This is a way to render carousels natively in CSS, reducing the dependency on JavaScript, which we like to see more of. However, this presents two issues. The first is the introduction of CSS inert. Inert allows for the carousels to be interactive. However, CSS is for styling, not behavior. This can lead to unexpected issues for developers. And there also already exist HTML inert, which may lead to confusion with developers on expected behavior of the two. Secondly, the carousel is not one element, but rather a component made up of multiple elements. The key way to give an element accessible names is through CSS content rule, which is not ideal. It's currently unclear if there's a way to give the carousel and slides accessible names which can be communicated to screen readers. The potential proposed fixes for CSS carousels. The first is to expose the accessible name for carousels and slides. The work is still being discussed between the tag and the CSS working group and trying to be understood on both sides. And then I think we really need to find an alternative to inert. The current tag recommendation is to find another method, but we do need to learn more about what has been considered. I now want to talk about some statistics just to help contextualize the features I've spoken about and also to contextualize where we are coming from with the societal impact questionnaire. There are currently 5.44 billion internet users. That's 67% of the global population. Out of the top 10 countries that have the most internet users, 7 are in the global south, with most of these users using 3G and 2G connections. That means most of the internet users in the world are using 3G and 2G connections. An estimated 1.3 billion people experience a significant disability. 16% of the world's population, and that's just an estimate, is likely more. It's clear that sometimes we make assumptions about who a web user is. While we have made strides in being more accessible and thinking about accessibility while creating new technology, there are still some assumptions that we have. We may assume that a web user is not cognitively disabled. We may assume that they don't have sensory issues or use assistive technology. They have high speed internet access with devices that are capable of rendering video and expensive graphics. They're in the top 1% of global wealth and can afford unlimited or high data plans. These are assumptions that make our tech inaccessible and the specifications we create inaccessible. The Societal Impact Questionnaire aims to encourage spec authors and contributors to the web platform to consider the consequences of their contributions. This includes considering who may or may not be excluded from the technologies we build. And just to quote the questionnaire itself, as we continue to evolve the web platform, we must consider the consequences of our work. Thank you.